The quotient rule is fairly long and complicated, and using it is not always the best way to differentiate a quotient. If the denominator of the quotient is simply a power of x, we can think about it as a negative power rather than as a quotient, and can avoid the quotient rule entirely. Similarly, if the denominator is just a constant, we can use the constant multiple rule to deal with it, rather than using the quotient rule. So in example 2 here, we have a function which is a quotient of two functions. It's x to the 6 minus square root of x plus 4x squared all over 2x cubed. However, the best way to differentiate this is not in fact to use the quotient rule, but to simplify first. So the first thing I'm going to do is I'm going to split this up as three separate fractions. We have x to the 6 over 2x cubed. We have square root of x, which is x to the 1/2 over 2x cubed. And we have 4x squared over 2x cubed. Then, x to the 6 divided by x cubed is x to the 3. 1 divided by 2 is 1/2. So we think about this as 1/2 x to the 3. X to the 1/2 divided by 2x cubed is 1/2. X to the 1/2 minus 3 is negative 5 over 2. 4x squared over 2x cubed is 2x to the negative 1. So what we've done is we've actually split this up into three separate fractions and done the division, and we've simplified into something which we can take the derivative of just using the sum, difference, and power rules. So now we want to take f prime of x, and we use the sum, difference, and constant multiple rules to pull these constants out. So we have 1/2 times the derivative of x cubed minus 1/2 times the derivative of x to the negative 5 over 2 plus 2 times the derivative of x to the negative 1. Derivative of x cubed is 3x squared, so this gives you 3 over 2x squared. Bring down the negative 5 over 2. Negative 5 over 2 times 1 over 2 is positive 5 over 4. We have x to the negative 7 over 2 minus 2x to the negative 2. So this derivative was in fact a lot easier to find because we did not use the quotient rule. I'm going to do a couple more examples of situations in which we do use the quotient rule before I go on to talking about higher derivatives. So if we want to take the derivative here of h of x, which is e to the x over sine h of x, we're going to use the quotient rule, do the derivative. H prime of x is going to be the derivative of the top times the bottom minus the derivative of the bottom, which is sine h of x, times the top, which is e to the x, all over sine h of x squared. Derivative of e to the x is just e to the x multiplied by sine h of x. The derivative of sine h of x is cos h of x. Multiply that by e to the x. And sine h of x squared we can rewrite as sine h squared x.